So just so you know, guys, between the last problem and this problem, I just ate 5 more of those crazy egg things. They're delicious. I thought I'd show you this. This is a cute little picture. This is Lena. We brought her out to the park, and it was a little cold out there, so my wife gave her this hooded sweatshirt to wear, and hopefully she can grow into it pretty soon. But yeah, she's using her little tyke thing. Let's see, do I have any other cute pictures? Look at her here. She's in her little rocker, and look how long. I try to cover her up. Those are her legs down there. I thought that was kind of a funny looking picture. I don't have anything else. Oh, and then Levi, he's got his helmet on. Check it out. This is kind of a cool picture. He's swinging for the first time on the big boy swing by himself, and I told him, do not let go of the chain or you'll do a backflip. And sure enough, he did do a backflip. So he learned his lesson. Learn by failure, right? Learn by failure. Let's fail on this problem, but maybe not. We are going to graph secant of 2 x minus pi over 2. Okay, so we got to figure out the amplitude, period, vertical shift, and phase shift in this one first. The amplitude is, again, the number in front of the secant being multiplied on the front of the secant. That is a 1 in this situation. The period is given by this right here. Oh, let's highlight it for us. Okay, the period given by this 2. That's going to be multiplied to the x. Okay, so the period is determined for secant as 2 pi divided by the b, and our b is 2, so the period is 2 pi divided by 2, which is pi. Okay. Phase shift is this number after this 2 has been factored out of there, which has been factored out. So we have a phase shift of pi over 2. Pi over 2. I understand this. Okay, don't do that anymore. Maybe I just can't put my palm down. Panning hand, that must be it. Okay, so the phase shift is pi over 2. And finally, the vertical shift, the up and down. Nothing was really happening on the outside being added, so there is no vertical shift. It's a vertical shift of 0. Okay, so now to graph this function right here, what you really need to do first is you need to find graph its reciprocal. And once you graph its reciprocal, we graph this function right here. So let's graph the reciprocal of this. The reciprocal of secant, if you guys remember, is equal to 1 over cosine. So what we need to do is graph cosine of this. So I'm going to call that a different function. F of x is equal to cosine of 2 quantity x minus pi over 2. Now all this information over here, the phase shift, the period, the amplitude, all that stuff still holds true for this, okay? So don't worry about that. That's period. There we go. Well, let's graph cosine of 2 x minus pi over 2. First, let's before we graph this, let's find the max and the min. Well, the max and the min can be determined by the amplitude and the vertical shift. The amplitude is 1 and the vertical shift is 0. Therefore, your max and min go up as high as 1 and as low as -1, okay? Now, if this amplitude was 2, it would go up as high as 2 and as low as -2. And if this vertical shift was, say, +1, then it would be 1 plus 1 and -1 plus 1. You'd have to take that vertical shift into account. But it's not. It's 0. So we're going to put in our little vertical shift line right here. So we know our graph is going to go between these dotted lines I'm going to put on here. You guys see those? I wonder if I need to make it thicker. That did not help at all. Okay. Now we know our period is pi, so it's going to make one whole rotation pi. So let's, or one whole cycle in a matter of pi. So let's put 4 dashes here, 3, 4. We'll make this dash right here pi. You know, one whole cycle will be completed there. We've got 1, 2, 3, 4, and this will be -pi. 1, 2, 3, 4. We get another cycle here. That's 2 pi. And then 1, 2, 3, 4. That's 3 pi. So here we should have 4 cycles. One cycle in this section right here. One cycle in this section right here. Go all the way to pi. One cycle in this section right here. And finally one section in this cycle right there. Okay, or one cycle. Okay, so now let's start graphing it. Now what you need to think about is, let's first graph just the cosine function. We know it's going to cycle in here, and then what we're going to do is we're going to do the period or the phase shift right here. But first we're going to graph just the cosine with this cycle right here. Cosine, as long as it's not negative in front, always starts up here at the top. And then at the end of its cycle, it ends where it starts. Okay, so it's going to end there. And midway through its cycle, it's going to pop to the other side. So it's going to come back down through here. And therefore, it's going to cross over at this point and this point. So you can kind of see the pattern. Every pi over 4, it's going to be either in the middle, top, or the bottom. So you can see it's going to come back down here. It's going to go back here. Going to pop back up there, and then all the way to the top. And then back to the middle, and back to the bottom. And then back to the middle, and then back to the top. And then over here in this section, it's going to go down to the middle, down to the bottom, back to the middle, and up to the top. And so we got this little curve right here, this cosine curve. Make it curvy, guys. I saw a lot of like absolute value functions when I saw your first graphs of these. So try to make it curvy, no bumps like I just did there. So there is cosine of 2x. We just did that part. But we still did not take into consideration this pi over 2, which is the phase shift. And I didn't even kind of label what that was. That's a phase shift right. Okay. So what that's going to do is going to take every point on here and shift it to the right pi over 2. Okay. So let's just think about how far pi over 2 is. If this is pi, then this halfway is pi over 2. And then this is pi over 2. But this is 1, 2, this is 3 pi over 2. Sorry, that. And this is 4 pi over 2. I didn't do that right. 3, 4, this is 5. Excuse me. Let me fix that. Nope. 1, 2, 4, 5 pi over 2. Okay, so everything gets shifted over by a pi over 2. So if this point's here, it gets shifted over to there. See how it got shifted over? This point's right here, so it gets shifted right there. This point up here gets shifted right there. This point right here gets shifted over there. That point right there gets shifted over, I would say about there. These points get shifted right here, so that got shifted over there. This got shifted over there. This point right here got shifted over there. This point right here got shifted over there. This point right here got shifted over there. And so your new function, I wonder if I can do this. Can I grab this? Insert, share, join, select. Can I grab this? Nope, that's not it. Lasso. Shoot, that's too bad. I was hoping I could grab this function. I'll draw the new one right here for you. So you can kind of see this new function going on right here. Going down and then coming back up and then going down right here. Goes down right here, right there. So curvy, 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 right there. And you can even kind of finish it off right there. So we're focusing on this green function right now. This, again, so this green function is this whole thing. I'm going to highlight it for you guys. Now, have we graphed this function? No, no. We're going to use this green function to graph it, okay? Now, here's what you gotta think about. Because this green function, let's make this, because this green function is the reciprocal of secant, there's something special that goes on at certain points in time. First off, you need to know that whenever you take one and you divide it by 0, or any number divided by 0, you get an undefined point. So whenever our cosine function down here, this cosine function is equal to 0, whenever this green function right here is equal to 0, we're dividing by 0, and thus we create a vertical asymptote. So at all these 0 points, you can put in a vertical line. So right here, you can put a vertical line as its asymptote. Okay, there's another asymptote right here. Oh, it's not going to go in. So there's a vertical asymptote. Can I make it? Let's make it dotted. Here's a vertical asymptote. Here's another vertical asymptote. Here's another vertical asymptote. Here's another vertical asymptote. Okay. These were all vertical asymptotes for our yellow function right there. Probably should have made these yellow then, shouldn't I? Okay. And now, we talked about this in class, but what really just to graph secant now is at the top of these peaks right here. I'm going to try to highlight each of them. Right there, right there, right there. The top of these peaks, you're just going to draw this little either upside a U or an upside down U. So it looks like this. There. Here's your upside down one for this one, and here's your upside down one for this one, and then there's this one right here. Upside down one right there, and then regular side U like there. Remember, they go to these vertical asymptotes. You need the vertical asymptotes. Make sure you're not crossing over these vertical asymptotes right here. There's that one. Here's this one, and here's this one. And this goes on forever. So if I can just, I'm going to highlight it. This is what it looks like. This is your final function that I'm highlighting right here. Right there. This function is this yellow function right up here. It's called secant of 2 quantity x minus pi over 2. There you go. So that's how you graph this function right here. Hopefully that's helpful. On the next problem, again, I'm going to show you how to graph 2, which is an amplitude, cosecant of 4 minus 2x. Notice this 4 right here has yet to be factored out. You need to do that to figure out the phase shift. Okay, you need to figure out the phase shift. So that will be in the next video. That's coming up right after I get a couple of those candy delicious eggs. Really, right now I'm going to get them.